Welcome to Ask and Learn.
Let's consider the reaction of copper sulfate and potassium hydroxide. For part A, before mixing, how many grams of copper are present in the copper sulfate solution? So we'll calculate the moles of copper sulfate, which would be the molarity times the volume. Molarity is 1.00 molar times the volume, but the volume is 50 milliliters, and 50 milliliters in liters would be 0.500 liters, and then the moles would therefore be 0.0500 moles. So this would be the moles of copper sulfate, 0.500 moles, and we want the mass of copper. So in order to calculate the mass of copper, in 1 mole of CuSO4, there's 1 mole of copper, so copper 2 plus, and 1 mole of copper 2 plus has a mass of 63.54 grams, and this would be equal to 3.18 grams of copper 2 plus present before mixing. For part B, we are asked to predict the identity of the precipitate. So we have copper sulfate, which will react with potassium hydroxide to produce potassium sulfate, which is aqueous, and copper hydroxide solid. So this here would be our precipitates, which would be copper hydroxide. To balance this, we'll put a 2 in front of the KOH on the left-hand side. For part C, write the complete and net ionic equations for the reaction that occurs when those two solutions are mixed. So the complete ionic equation would be Cu2 plus, SO4 2 minus, 2K plus, 2OH minus, 2K plus, SO4 2 minus, CuOH2 solid. And then based on this, the net ionic equation, eliminating spectators, eliminate the K plus and the SO4 2 minus. So our net ionic equation would be copper 2 plus, 2OH minus, produce a precipitate of copper hydroxide. And for part D, we're asked to calculate the delta H for the reaction upon mixing. So delta H is equal to Q, which is equal to MC delta T. So this would be equal to, the mass is 100 grams. And C is heat capacity, 4.184 joules per gram Kelvin. Delta T here is negative 6.2 Kelvin. And this would work out to negative 2.6 kilojoules. And this would be the value for delta H for this reaction.